This update is to show where I'm up to with the guards on the Austin and a few other little bits and pieces. I've finished the welding, the cutting and the welding and the wiring on the front guard. I still need to do all the hammering to get it smooth, but it's more or less there. It kind of shows the shape quite nicely now, and also shows the positioning over the tyres. You may notice that this guard has a big weld down the middle of it, and that's because I made a small mistake, which was when I welded the top on this, I just grabbed the pieces of steel that I'd cut, completely forgetting that I'd cut them oversized so I could trim them nicely later. The cuts I'd made were so neat, it just looked like it was the final cut. So when I welded it together, I discovered it was about 1 inch too wide down the middle. So I ended up having to slice it all the way down the middle and welding it back together. So it's going to take quite a bit more work now to get this all smoothed out, hammer it all smooth. And I have started doing that. It's quite a lot of hammering. You can sort of see where I've started doing it around here to get the curve correct. If you compare it to the other side, you can see this is all still wavy because I haven't been hammering it yet. So this is all going to get hammered and filed just to get it all back into shape. I think even then it's going to need quite a bit of filler to get it smooth, but it's my first go at this sort of stuff, so I'm not too worried about how that's come out so far. And I can always make new ones later. But I'm definitely getting better at doing it and better at doing the wiring. The other side won't have this huge cut down the middle, of course. The other thing I did was I got sick of trying to balance the guards on top of plastic bottles and bits of wood and things. It was very unstable and it would keep falling off. So I ended up making these little wooden cradles that are shaped to fit the tyre, and then I can stack other blocks of wood on top to lift the guards to the correct height. So those are just made from some scraps of wood, and I made one at the front there, and there's another one at the back, just for the rear guard to get that sitting up in the right place. Getting the curve of the tyre, I used a trick that I learned on one of my metalworking videos. I can't actually remember which one, but that's when you take to a neutral background, a strip of steel, a straight strip of steel, and then you can use the shrinking or stretching jaws. I have the stretching jaws here. You can see as you move the lever up and down, the jaws move apart, and so when you stretch the edge of the metal, it makes it longer, so the piece of metal has to curve. And I used that, curved that until it matched the profile of the tyre, and then I had a template to trace on the timber to cut it out. And that works very well. It's very quick to do. And of course I had lots of thin strips of steel left over from when I'd trimmed the middle out of the guard. The other thing I've been doing is I did have the clutch plate for the Riley relined. So this has got new lining bonded onto it, and I now have a parts order on the way from the UK, which is the clutch springs, the thrust bearing that goes inside here, and the bolts to bolt it all together. I am looking at making a new nut. Now that I've got the lathe and the mill, I should hopefully be able to have a go at doing that myself. So we'll have to see how that comes out. This one looks a bit thin for some reason. I'm not sure exactly how thick it should be, but that's something I can have a go at. The other thing I want to do is look at lightening the flywheel, because you can probably see it's a very huge lump of steel. And so what you can do is you can actually lighten this. You can have some machined off it, which obviously I can't do on my little lathe, but I'm hoping that the place I go for engine balancing might be able to do that for me. The other thing I've done is I've been buying various bits and pieces for the mill, and I spent some time to get that set up properly. So I've done what's called tramming the mill, which is where you ensure that the surface of the table, I've just got it covered in some pieces of timber to stop it getting damaged. you make sure that the surface of the table is completely perpendicular to the bore of the spindle here. And unfortunately on this type of mill, which is the circular column type mill, the only way to adjust it is by adjusting the positioning of the pedestal on the base. And the way you do that is with these little shims. So what you do is you use a dial test indicator on an arm that comes down and swings in an arc around here, and you rest the indicator on the table and you measure at certain points around the table until you get the measurements all the same. And what that's showing you is, as you rotate around the spindle in an arc, in a circle, the height is exactly the same above the table. And of course that's important so that when you machine things they come out square. So what I ended up having to do was unbolt this, loosen these bolts, there's two on the other side, and insert shims into here, then tighten everything back up and remeasure it to get it down as accurate as I could. My dial test indicator measures down to 0.01 of a millimeter, and I managed to get it leveled to within one division, so less than 0.01 across there over about a 400 millimeter diameter. It took me about 17 goes, I think, of unbolting it, bolting it back up. And you have to bolt it up hard, of course. It has to be done completely accurately. But once I got that done, it was all set up, and now it's all bolted together. And the other thing I did was set up the vise so that the jaws are completely straight in the y-axis, so that when you clamp something in here, you know that it's straight. Again, you use the dial test indicator to do that. One of the things I did do is take the swivel base off the vise, because it seems like a lot of people recommend doing that, because one, it gives you extra height, because the base takes up quite a bit of space here and you need the height above the work, between the work and the tool. And also it just adds another potential area for loss of rigidity. So on a machine like this, what you can do with it is kind of limited by how rigid the machine is, and that's basically how much flex there is in it. And it's quite surprising how much there actually is. So with the dial test indicator indicating off the base here, if you push hard on the column, you'll see the needle move. The same if you have it resting on here and you push down on the table, you can actually make it deflect. And of course, when you're cutting something in here, there's going to be various forces on it, and that all causes deflection. So that limits the size of the cut you can take. On a home machine like this, compared to a big industrial machine, it's not going to be anywhere near as rigid. So you just bear that in mind and you work around it. But I've also been buying various useful bits and pieces, the 1, 2, 3 blocks, which until you actually start getting into this sort of stuff, you wouldn't think they're very useful, but apparently they're useful for all sorts of things. I've got various other tools coming. I've got a set of parallels coming, which you use inside the vise to hold things up. I've got some cutters coming, various collets and all sorts of things. The other thing I did order is a digital readout. So even in just my short time playing around with this, I've learned how important it is, or how difficult it is, just to use the hand wheels, because you have to take into account the backlash. So you can see as you move that, there's a little bit of movement before the table starts to move. And when you're machining, you have to take all that sort of thing into account. With a digital readout, it gives you the absolute position of the table relative to the machine, which makes that sort of thing a lot easier to do. So that's on the way. I did practice just some milling, and I basically made a little right angle thing, just to make sure I had everything set up. And that turned out to be pretty accurate. So accurate enough for the sorts of things I want to do, which will be trying to make a replica of this bracket out of some angle iron. And then if I can make this side, I can then make the other side, which is where the steering box attaches down there. The other small thing I've done is I was looking on Trade Me. I always keep an eye out for various vintage bits and pieces, anything that could be useful. And this mile per hour speedometer came up. And it was a reasonable buy now, so I just grabbed it because I thought it might be useful. It's the right sort of period speedometer. And turned out to be sold by a guy who has a replica, a Riley Special. And he'd restored that and taken these gauges out of it and put in a new set of Smith's gauges. So he was selling this one. And when I got it, I was pleasantly surprised to find out that it's actually a chronometric speedometer, which means inside here there's a little clockwork mechanism, and effectively it samples the rotation of the input shaft and moves the needle in relation to that every second or so. So it gives you a very sort of jerky motion. Let me just move this light. Very, very vintage looking motion. I'd quite like to get a tachometer that does the same thing. So I took this all apart, wasn't too hard to do, stripped it down, not completely, just took the clockwork mechanism out, cleaned all that up, got all the old oil and grease which had sort of gummed it up off. Just carefully used some warm soapy water to clear off the face and the needle and the drums, the digits here. You do have to be very careful with these drums. If you get any sort of solvent near them, it'll just take the paint straight off them. I sort of learnt that lesson on my Austin 7 speedometer, where I accidentally lost a couple of the digits. But on this one I was extra careful. And then once I'd cleaned it all up, it all looked fine. Apparently they're very robust. And I just gave it a very, very light oil. I actually used oil that you use on model railway locomotives. It's very light, very high quality oil, and just the most minute amount. And the thing now works fairly well. So I've got it set up on my electric drill through a little short piece of plastic hose as a coupling, and if we start up the drill we should see how this works. See if I can rotate this. The interesting thing is if you stop immediately, the needle doesn't get a chance to reset back to zero, because it hasn't finished its time period of sampling. So I wonder if that means if you crashed and came to a sudden stop, it'll show the speed that you were going at the moment you crashed. But it works fairly well. I'm pleased with how that works. Obviously in actual road use it's going to be a lot smoother than that. I mean, it's going to be, the speed variations aren't as big, so the needle won't jump around quite as much. But I'll have to keep an eye out for a matching tachometer.